For my Lab 9, I decided to make a clock using a step motor. So I have this Redskins board with the clock numbers on it and a step motor in the middle with an arrow on it to tell the time. And I'll connect it to this circuit here. The step motor is connected to an H-bridge within those wires, very similar to the way we did in Lab 7. I have this battery pack that is connected to the H-bridge, and this potentiometer here is connected to an analog pin, and that is going to help with something we'll see later in the Arduino code. In the Arduino code here, the void loop section can do one of two things based on what this potentiometer value reads. If the potentiometer value is over 512, and remember that the range is from 0 to 1023, the motor is going to move at the normal 12-hour pace. So these 4 blocks here are just the commands that make the motor turn 1 step, and there's 512 steps to get all the way around, just based on the specifications of a step motor. And the way we make sure that it takes 12 hours to go around is with this loop right here. So there's a delay down here, which prevents the loop from starting again. And we see there's 625 times through this for loop with a delay of 135 milliseconds each time. And so the math behind that is right here. We know that there's 512 steps for the step motor, and there's 43,200 seconds in 12 hours. So to get the number of seconds between steps, we need to do this quick division to get 84.37 seconds. However, an issue arose with that, because if we have to delay 84 seconds each time, then the potentiometer value is not going to update during that delay. So we need to have a lot of iterations through. So I chose 625 because that was a factor of 84,375, and so that brought me to this 135 millisecond delay. And now the other possibility, the potentiometer value is low and under 512. It takes us to this loop down here. And this one's a much quicker loop. There's no delay, so the clock will rotate much more quickly and allow you to stop and set the time as you please. To demonstrate how this Arduino code works, I'm gonna upload this sketch and check out the serial monitor. And right now, the potentiometer values are high, so it's in the 12-hour pace. But if I move the potentiometer to put the voltage down, it's now in the set time pace. And I can stop this whenever I please to set a time. So if I want 3 o'clock, time is now stopped at 3 o'clock. So for the processing code, I wanted to make a visual representation of what the potentiometer is doing and what the circuit is reading. So if I run this, the screen is going to pop up with an outline of a circle and a big red circle. And the circle is controlled by the potentiometer values. So I can make it bigger and smaller, and it will determine what mode it's in. So now, the circle is big and the clock is set mode, and it is not moving. However, if I turn the potentiometer into the set time circle, now we see that the arrow is moving. So now that I've explained how my clock works, I'm going to use these command strips and put it up on my wall and see how it looks. So now the clock and the electronics are on the wall. Thank you for watching.